All right, guys, we have about a minute left, so I'm just going to wait a few more seconds before we get started. There was a question I already answered. So normally these workshops try to keep them under 60 minutes, and we try to keep them as practical as possible. And the Q&A normally happens at the end, but if there's like a burning question you feel we need to answer right there and then, just drop it in the comments and I'll stop to answer it. Provided it doesn't really interrupt the flow and it makes sense contextually. But other than that, I want to be mindful of the time of everybody that actually made it on time. Seeing some familiar names, so nice to see. Actually, a lot of you that came from the previous show. So, without further ado, I'm joined today by Graphiti. And in just a few minutes, we're going to be joined by Roy Lipman. He's the CTO of FalkorDB. Today, we want to share with you our take on implementing agentic memory, what our definition is of an agent, how we perceive memory, and what is Graph's role in memory for an agent. To do that, for demonstration purposes, we're going to share an open source project that we've developed called QueryWeaver, which is essentially converting natural language into SQL that it then runs against several databases to return a response. So without further ado, there's three of us today, and we each want to share something. So I'm going to start us off, and I'm going to hand it over to Gang. He's going to share his screen and do both a demo and his his portion of the presentation. And just for those who've just joined us right now, feel free to drop your questions on the Q&A panel, should be on the bottom right-hand corner. For those on Discord, drop it where you normally do. And we'll also be monitoring LinkedIn, even though last time it didn't work so good. So let's try to keep it here and on Discord. So with that being said, let's get started. What we want to do today, a bit of an agenda. So agents, what are they? Why they need memory? Why we think that memory should be graph-based, and what to do in terms of privacy and scale. There's a demo and a Q&A in the end where you can essentially ask any question about what we've presented here or anything that really comes to mind about this topic. Just a bit about who we are. So Roy Lipman, who has joined us. Hey, Roy. He's the CTO of FalkorDB. Graphiti is an AI engineer that actually developed QueryWeaver and is actually in charge of the implementation you'll see here today. And I'm Dan from marketing, hosting this session. Without further ado, we want to get right into it and dive deep. So what is an agent anyways? And this is the point I'm handing over to you, Gav. You're the expert. So really happy to hear from you. Take it away.
Let me share my screen.
Sure.
So, what is an agent anyway? Thank you, Dan. It's great to be here again. And before we dive into what is agentic memory, I want to align of the definition of what is an agent in overall. So, as an agent is a software component that powered by an LLM that designed to perform tasks and can take actions like tools, interactions with other agents, but generally it's a software component that get inputs and needs to take specific tasks. We provide this agent some tools in order to give the agent the opportunity to perform the task well, and design the output that will be fit to the next step of our pipeline. Maybe it's agentic flow. But the task is very important for our next step. So one of the tools that we want to bring in to our agent is the memory. We want the agent to be able to learn over time, learn about the environment, the task that he need to perform, the persons that talk with him, maybe the other agents that is around him, and we need to give him the opportunity to succeed to do this task. So in order to do that, we bring to the agent three kind of memories. This is our approach to bring memories to the agent. And we do that with give him some past context references, maybe give the system how to learn from previous interactions, some personalization, the user preference, who is the user, some basic knowledge about the user, maybe about the the agent around them, um, and some understanding about how he performed the task in the previous interaction. Maybe he succeed, and we want him to return on the similar steps that he done. Or if he fail, we don't want him to return the same failure again. So over time, we don't want the agent to start from zero. We need to give him tools that create the environment that continue with time. Okay, so what we're going to see today is an agent that's part of an application that we developed over the past month, the application called QueryWeaver. And what we actually develop is an application that we insert natural language, our language, and get language in natural language after we talk with our database. In between, we have an agent that does that perform text to SQL. So any input, any user question, converted into SQL, execute by the database, and give the user answer in a natural language. In order to give the user a good answer, we need to bring him some schemas. So we give our agent two tools. The first tool is the schema extractor, and the second tool is memories retrieval. So both of these tools give the SQL generator, the LLM, opportunity to uh, convert the natural language into SQL well. Okay, so how we implement the memory part in our SQL text to SQL agent. So, like I said, we have three kind of memory: success and failure. We want the our agent understand when he failed and understand when he succeed, and we can learn on the current interaction. So we save into the graph these three components. So the first component is the queries, and we connect them to the database nodes with a relationship that said success and failed. And when we retrieve, we can understand the context between the last queries and the results. The second memory is the user profile. Each time that the user explains himself, introduce, ask about some preference for the future, we update the user profile. It's represented as a node, and we extract it anytime we want to create to perform the task again. And the last memory concept is the conversation history. We do that with Graphiti. And what we actually do, I will show you next. We give the Graphiti the conversation, and we save the last episode connected to the nodes. So everything is connected in one graph. Okay, so let's talk about how we insert memory and how we extract memory. So like I said, we have three kinds of memory, and each time you ask a question, we extract the user profile, the past conversation with Graphiti, the most similar facts and episodes for the past conversation, and the similar queries with the results. I will show you next how we save them. We extract it from the graph, and when a conversation ends, we need to define what is conversation, but in our case it's a Q&A. But when a conversation ends, we insert it to the graph. The first thing is to extract the user profile, update the user profile with the current conversation. Maybe there is changing in his preference, maybe he inserts new memory, or maybe we need to delete from the user profile. The second thing is to add the past conversations, the overall memory used by Graphiti. We rephrase this Q&A into one string, like one phrase that in order to align the conversation between the database and the user, and to give the Graphiti the way to extract the entities right. And we save the query results based on the results of the query. Okay, so after we understand how we insert and extract memory, let's dive into some core functions. So I will go over three kind of core functions in our implementation, but I want you to know that all this project is an open source. You can see all the implementation, and you can review it in yourself. So the first function is the function that we add new memory. He gets the conversation and the history and summarize the conversation. This is the rephrase part, and add it to Graphiti in that way. Any view that use Graphiti in the past know that when we add episode, we do it in this way. I will show you in the demo how it looks like in the graph in real time, but we give it a name. We insert the body of the episode in related to the database. Database is very important because any graph memory that we use can store more than one database, but it's per user. So we need to add episodes per database, and we also explain it in the description. Another thing that we do, we update the user information. This implementation you can see in our GitHub repo. We do it simultaneously because we don't want to stop the pipeline or that user feel this. For the query result, we use Cypher query. I hope you know, and any of you that don't know, I recommend to learn. But we connect any results to the database, the entity database, and we save the user query, the SQL query, the success or fail, and the error timestamp and embedding for following semantic search. We connect them with the relationship type, as you saw in the image in the previous slide, and save it in the graph. For the search memories, how we extract new memories, old memories, we use function that you can see in the GitHub repo, but we extract the user profile. I will show you how it looks like, the database facts and episodes, and retrieve similar queries. We also do it simultaneously in async way, and create one string that called memory context and provide it to the LLM in order to convert it to SQL. Okay, so that's for the theoretical part. Let's dive into the demo.
That was actually very interesting how you connected everything.
Yeah, I was gonna
It
say
really
same.
connects with our previous webinars.
Thank you, Dan. And let's talk about the demo. Okay, so I will jump from the demo and our graph visualization. Any of you that was in our last webinar saw this jumping between visualizations because I want you to see how the data is stored in our graph and what kind of memories is in reality. So I flashed my memory, and now I have only the database node and the user profile. This is my user ID. So this is the QueryWeaver that we talked about. It's open source and free to use. Feel free to use it and give it a star if you enjoy it. And we will see the demo. I will show you the demo about a demo of CRM. And we generate a CRM database with Postgres, and he has some data, so we will see how it's work live. And we can see the schemas, how the data is stored in our graph, and how the data is stored in Postgres. We store the schema in the graph. But let's see how the tables, and I'll explain how the tables that I'm going to show you today are connected. So I will ask about tasks and users that related to me in order to show you the tree concept of memory that we implemented. So this is very cool visualization, and I use it a lot when I ask questions and want to debug them. Okay, so let's see the demo. So I will let's start. Okay, so I will ask something that will emphasize the needs of memory. So let's ask, please create a monthly report about my tasks over July 2025. Okay, this question is stored two concepts. I want him to understand that I'm talking about monthly report in the future, and to understand who I am, because he don't know who I am. And for us to do that, he need to understand this and ask me who I am. So I will say my username. My username is, and I prepared it before because it's a generated database, is salesrep1. So now we want him to recall it in the future. What is my username? And anytime I will ask something, I want him to know my username or try to use it in the future. So you see, he confirm it. He used the sales rep. He created SQL, executing with a database and extract output in our language. Let's see how it goes after we reset the conversation. So I will ask, can you generate the report that I asked last time for August? And now I want him to understand which report that I'll ask. So is my tasks, and that I am the rep one, like using my username. Okay, so as we all know, I have a lot of tasks for August, but he succeed. Okay, he understand which report that I want. I asked him last time, and what kind of preference or user identity he have. Okay, before we ask the next question, let's look how it looked like in our graph. We will generate the query and see how it's look like. So as I told you before, we have three kind of queries. Okay, we have the three questions that we ask connected to our database. Let's look how it look like. So this is the property of a knowledge graph. We can use them in order to extract data for our LLM and give him more opportunity um, to answer complex questions, and we use it to store, like I show you in the function explanation, to store the query results. So the user query, the SQL query, if it's success or not, and the embeddings for the part we extract. This is the database. We have also the user profile. We store it as an summary, and I will show you what wrote in there. I will have the notes, but the overall summary, the user identified by the username sales rep, utilize QueryWeaver, yada yada, personal information, and this is the way that I store the user profile for next usage, and any question, it's updates for better question in the future. We also have entities and like episodes that we stored um, with with Graphiti. So the overall graph that created give the LLM as a memory the environment you need to know about the databases and the user environment and what you need to perform and how it will improve over time. Okay, let's continue with our demo. So now we have task of August and we can ask about these tasks. So let's say which one of them has high priority. Okay, so this is demonstrated the working memory because I'm asking about my last question. It's pretty easy, you already know, but we connected it also. And you can see that I'm asking about high priority with small case, and our app knows how we store the priority in the column, or how we store the text in the column, and uses the high priority. This is our taxonomy feature. And it gives me an answer. Let's try to add more user profile. And we said which task is due on a day before my birthday. So I want him again to ask me which is my birthday or which date is, when is my birthday? And to extract the task based on that. So perfect. He asked me about my birthday, but ask again about the username. This has happened. We need to insert the memory to this part also. But what I'm going to say to him is what is my birthday. My birthday is on the 2nd of August, 2025. Yes, I'm very young. Oh, I have a typo. I hope he will understand. But he was understanding because it's work with LLM and he has some understanding about text. And he succeeded. He extracted the task that connected to the 1st of August. Okay, let's flash or reset the session again and ask him something about my birthday to emphasize this feature. Tell me how many days are between all of my tasks, due date, and my birthday. So in any question that I'm asking, we extract the tree concept of memory and give it to the text-to-SQL agent as a part of the text-to-SQL agent in the prompt. And anytime that I'm execute query that succeed, we also insert it to the graph, and this is part of the prompt. So what we saw here is how we use the preference memory and the last conversation memory. But in the other line questions, we see how he understand from his past success how to improve or how to execute the following queries. So as you can see, he succeed to do that, give us a table and explain in natural language. And let's try to ask a complex question. And we will hope for us to see that that he will fail to convert it to SQL. But as you already know, we working with statistical models. So sometimes they succeed and sometimes they fail. But if he will succeed, he will do that again because he have the memory. So let's try to see if he will succeed with this query. So I'm asking him, how are the customers with the highest and lowest sales volumes, and how is this company's associated account managers? Let's see what happens. Okay, so he succeed because he's smart, and he succeeds to create a very complex query with joins, multiple joins, and do some multiplication and give us a natural language. So in this way, we saw how he used the success way, but if we think about it, if we give our agent memory about failed queries, he understands not to do them again. And we won't see them in this demo. So I think that's it. I hope that I gave you some pure concept about how we implement these memories in our application, how we understand what we want our agent to perform, what he needs to perform his task well over time, and the functionality here. So thank you, and Dan, you can take it from here.
That's really good, Go. Actually, I'm seeing really interesting question getting pulled in the Q&A. And just before we jump to those questions, we do have a few more things we want to share. And actually, what Roy is going to present in just a few seconds, we'll partially answer some of them, and then we'll address each one individually. So I'm just going to share my screen and just do a little bit of recap of everything you've seen so far, whether it was theory or practice. The need for memory is clear. Our implementation, I think, is quite sophisticated, and in terms of functionality, it works. Now, some of the questions do speak to the functionality, so let me address those in the Q&A. But Roy, I want to hand over to you to talk about Graph's role in everything that we've seen here.
Yeah, thank you. I would keep it short because I want to leave time for questions. I saw some really interesting questions, so let me run through this. I'm just going to give some information about graphs and our particular solution, FalkorDB. As agents are becoming more and more popular. We see a lot of use cases for graphs in them. The first one, which was introduced or revived just recently, is knowledge graphs, but now graphs are also being used to store memory. And in this demo, we're also using graph to hold the entire database, relational database schema. And so with those type of applications where there is user interaction, um, first of all, you don't want to have the database as the bottleneck. And so with FalkorDB, our emphasis has always been on providing a low latency and a high throughput database with a small memory footprint. So that's come in handy for almost all use cases, not Gen AI specific. But with memory and knowledge graph, I think that the schemaless feature of graph databases really shines. Unlike relational databases where changing a schema is not that easy, with the property graph model or with graph databases, you're not committed to any schema. You can add new attributes or create new type of relations or type of nodes with ease. So these are important features to take into consideration whenever incorporating a graph database. And you always want low latency and high throughput. So FalkorDB is in a top contender position to provide you with those features. If you can move to the next slide, please. Now, in terms of memory and knowledge graph, I think that two key features that are really important to keep in mind is first multi-tenancy. That feature which enables you to maintain multiple graphs, disjoint graphs, all within a single database really comes in handy. Because what you're going to see is that for every user that you have, you're going to provide that user with its own memory. And that translates into a graph. And so if you have thousands of users, then you have thousands of different memory graphs to maintain. And FalkorDB gives you all of that in a single database as multi-tenancy. Another thing which is important to have is a database that speaks a common or a well-known query language. In our case, that's Cypher, which had been around for a long time, and different LLMs know how to translate natural language to Cypher. So that's something that really comes in handy. And maybe one last thing is the semantic index. You might know it as vector indexing. So that's another type of index that we support and is being used over and over again in agentic use cases. So thank you for listening, and we will be happy to take a few questions.
Exactly. Just in conclusion, guys, so decide what the agent needs to remember, how it's going to store its memory, and pay attention to how it handles privacy and scale. With that being said, if you did like what you saw, we would appreciate a star to support our work. And let's kick things off with your questions. There was a question I wanted to get started with because it's very relevant to what we've discussed so far. Let me just pull it up. So the question comes from David. It asks, does it work for complex schemas, 50 and I'm imagining 50 and above, tables with many relations? He mentions that he's working with OMOP, CDM in healthcare.
Yeah, I will take that. So first, that is a question about our agent, and not related to the memory. But if we want to answer it, you can see our technique in the GitHub repo. But our technique based on graph, we store the schema of the graph of the database um, in our graph store in FalkorDB graph. And anytime you want to retrieve some schemas, maybe it's large, like 100, maybe more, 1000 tables, we extract the relevant parts from your questions, find entry points in the graph, and traverse between the entry points and extract all the tables in between. So we try to overcome the gap between the context window of the LLM, because most of the time, and I suppose your question comes from the lack of context window for your LLM, and the relational database, a complex relational database with store the graph, store the relational database as a graph, and extract entry points with a similar or semantic layer, and use the graph ability to traverse and extract the relevant tables that connected between the relevant parts of your questions or the user questions.
Thanks, Carl, for this. We've actually pulled quite a few questions, so I just want to make it clear, we will get to everyone, even if we can't do it within this session. We usually compile all of these questions, we answer them, and then we send those in an email just to those who have attended, so no worries if we can't get to you. I'm just gonna, just for sake of fairness, read them from top to bottom. The next question comes to us from Arush, hope I pronounced that correctly. He's essentially referring to when we were showing the demo, I think this question came in, he asked, is it going to ask an SQL query every time, even if it has the retrieved data from the previous prompt? And he qualified that with, basically, if it has retrieved SQL query earlier and the user asks the question again, does it use history or will it query again to the database?
Okay, so it's a good question, and I hope that I understand it correctly, but yes, it will convert it to SQL and execute same query again to the database. But the memories part here is when you ask it again and you ask same question that related to the previous query that was executed, it will know how we performed the last query and convert it to a valid SQL query. But you're right, maybe in the future we can use the query and the results from the query for memory also. It's a good point.
I agree. The next one, I'm seeing it's not really a question. So I'll just read it out, and I think he's sort of like making the statement. I think the first half, I think, is right, and let's comment on the second half. So he's saying, I am confident that I understand the concept correctly. You have defined a graph that maps the schema of a database, in this case, CRM and PostgreSQL, so that's correct. The nodes are the tables, and the columns of the tables are the properties. During a query, the graph is expanded with, among other things, the user properties, for example, a username. So I think the first half is definitely bang on, but let's speak to the second half of what he asked.
Yeah, let's clarify it. It's we build two separated graph, completely isolated. There is the graph that contain the schema, the tables and the columns, they are nodes, and the relationships between them are their relationship in the reality, in the relational database. And like you have table, the table has columns refer to other columns, and other columns refer to tables, and that's how they connected. And the other graph is the memory graph. So the memory graph is isolated, and we can achieve it because we are tenancy graph, and we can build graph for each case and isolate it from other graphs. So again, I hope that is clarified his question, but the schema is one graph and the memory is the other graph.
Yeah, Gal, I want to add to what you said before. I think this comes from experience from our previous workshops. So all of us, everyone that's presenting here today, we're also available on Discord. So if you feel like you want to ask a follow-up question to everything you asked here, just find us on Discord. We're very happy to pick things up in case there's a sharpening that needs to take place to the answer you received here today. I want to move on for the sake of time to make sure we get through more of these questions to something I think is a very good question. It comes from Smriti Kotyal. How long is the memory saved? Also, are you creating another node in the graph for personalization or saving this like your birthday information somewhere else? So
Okay.
I wanted us to touch on that.
So that's a very good point, I think, because two things. We want to save memories that maybe in the future we'll erase from the memories because we forget them. But in the current implementation, we implemented the memories that will stay here forever and has the time relevancy, like we introduced with Graphiti. So anytime you say preference, like your birthday, it's inserted into your profile and stay there like until you erase the memory. We thought about some ways to maybe erase memory in the future. This is why we adding the timestamps. Any timestamps can be used to erase old memories that didn't be used a lot of time. This is our approach for developing it in the future. But what I'm trying to say, and I hope that answer the question, is the memory that I show you today is here to stay. Every query is here to stay, and every nodes that add into the graph will be used in the next interaction.
Yeah, I'm glad you touched on that. And I think there was a previous question that somebody asked us to expand a little bit about Graphiti. So there is a link to the workshop we did before where we've actually built a knowledge graph with Graphiti that from structured and unstructured data that was really cool. And I think that when Gal touched on the temporal aspect in his answer, that also comes to us as a benefit from using Graphiti. The next question we're getting here is, sorry, did you want to add something?
Yes. I will touch it again. Graphiti add nodes, temporal data for each node as a property, and when it's created and it's valid, and when it's invalid, if it's invalid in the future. And the way that I'm creating the graph of the memory is with the ontology of how Graphiti used. So any nodes that I'm custom adding to the graph, I'm using the Graphiti method to create it and give it the temporal aspects of how they did, because this is a pretty good feature of them.
Great. Next question is from MS. Is FalkorDB capable to provide answers about data stored in its graphs in real time or near real time? I like this question. I have a use case where an agent is supposed to provide facts about certain data points and communicate their results in real conference calls. So the latency here is very critical. I think, Roy, this is a very good question up your alley.
Yeah, so that's what we are designed for. It really depends on the data set and it really depends on the queries. But for the majority of what we've seen and the way that we go about running queries, storing the data, FalkorDB is extremely efficient. I think that my best answer to you would be to take it for a spin and try it out for yourself. But from benchmarks that we've conducted using different data sets and using different queries, the performance are just unbeatable. So I hope that you would find it suitable for your performance needs, and we would love to get some feedback.
I agree. I think there's another question here directly after it that kind of ties in with the first question. It's from an anonymous attendee, so you're probably going to notice that when I read it out loud. How feasible is it to scale FalkorDB with or without Graphiti with hundreds of gigabytes and potentially terabytes of data? I've seen firsthand how well Falcor performs, thank you, with smaller amounts of data, but haven't had the chance to scale it yet. I'm particularly interested in memory usage, given that it uses Redis so much under the hood. Thanks for the compliments. Roy, do you want to take, I think it actually ties in with a blog post that we released a few days ago. I will send that out in addition to the recap of this workshop. But Roy, what are we thinking?
So I think that the questions need a little bit more explanation to it. If you're referring to what Gal had presented, where you have relational database storing hundreds and thousands of gigabytes of data, the type of application that Gal presented does not require this data to be stored within the graph. So that's one way that the question can go. But if you actually need to store hundreds of gigabytes or terabytes of data, it once again depends on, are you planning to have all of this information in a single graph, or do you see your data model where you break all of the data that you have into multiple graphs? FalkorDB, from performance perspective, keeps all of the information in memory. We don't want to reach out to disk in order to pull some information needed for a query, but because that would be a disaster for performance. And so if you have so much information, usually it is within our hope that you can divide it among multiple different graphs. And if that's the case, then you can actually scale out using a FalkorDB cluster where you have multiple machines, each one hosting a number of different graphs. And so all of your data is spread across a cluster.
And I wanted to add that if you ask in terms of memory and what I showed in the demo, or we showed in the demo, any new memory is or the concept of new memory as a deduplication, and we try to find similar nodes and deduplicate them. So it's designed in the way that it will scale if you use it a lot. But if you working with us with FalkorDB, and like Roy said, we have the ability to scale.
I want to so this question brings us back a little bit to the demo that you've shared, Gal. This question comes to us from Arthur. Did you leave the entities/ontologies creations to be defined by Graphiti, or is there any predefined schema? And if you did, what do you think are, or maybe, the trade-offs?
Okay. This is a pretty good question because we are faced the same decision, or like the same question with ourselves when we talk about it. And in the demo, in the POC, or like the application that we published, everything is defined. Also, Graphiti is defined the ontology that's saved in the graph. We have entities, we have episodic, and we have summaries. but everything is defined. We have the type property, but the ontology that we used in the graph is defined. Also, what I showed today is defined because we have the query, we have the episodes, and we have the entities. Everything is defined before, like the ontology. And this is there is trade-off here because we want a way that will be fixed in the future to save memory, like same kind of memory or like ontology, like I said, semantic memories will be saved in a similar way, and there is no way to make new kind of memory. There is no way to extract, I don't know, maybe other concept of memory. If you give the LLM or like the ontology to be modified over time, you give the opportunity to learn new kind of memories and give the application maybe more like humans. We understand new concept of memories, but in our agent, and I suppose in most of the agent, we want him to perform specific tasks. And to be able to perform this task, we want to give him kind of reference from the past. And this is what we call memory, and in our application is defined ontology.
Gal, there's a question that directly ties into what you were speaking about just now from Mark Lozano. So he's asking, what do we need to think about if we have memory that's based on Graphiti or FalkorDB running long term? Do we need to come up with a cleanup task to prune memories, or can we store without worrying too much about that?
Well, it's a good question. I think I touched about this question when we took a previous question. I think definitely we need a cleanup method. Our cleanup method, like I said, is to erase memory that didn't be used and for a lot of time. But I think in the beginning we don't need to worry, but at sometimes there is a lot of memories and we need to think about how to clean it. What is the proper way? For our approach at the moment, and I think we need to develop it in the future, is to erase memories that was in the graph a lot of time and didn't be used.
I'm glad you ended on that note because it actually answered another question that was there regarding bad memory. So I'm going to take that as answered live because I do feel it covered this. So as you were answering, well, we just have an overwhelming amount of questions, and I do have one thing I want to share before we essentially end this because we're very close to our mark. First of all, I want to thank you guys for taking the time to jump on this workshop and submit those questions. Those are good questions. Some of them are challenging. We want to take those offline and answer them in a little bit more detail than what we could in the few minutes that we have left. Before I let you go, I do want to make sure you're brought up to speed on the fact that we have an upcoming lineup of workshops that are tackling different important aspects of working with agents. And also for those that were more interested in the graph aspect of what you've seen here today, there's a graph visualization with G.V coming up in November. We're putting something together regarding chatbots with persistent memory with 2 open source projects from our community built by developers that we want to feature. And there will be a GraphBack text to SQL deep dive on QueryWeaver coming up as well. So I will send out links to all of those. If you've signed up from Luma or LinkedIn, you'll get a similar looking invitation as well, so you can sign up to those. If you liked the demo that we've shown here today, really appreciate that you hit the star button. Helps us reach more developers who are going to try this tool. Like God said, it's open source, so feel free to go check it out right now. It's just app.queryweaver.ai, or just scan the QR code that I have here on my screen. And that concludes our workshop for today. Those workshops you see on screen, I think, are really interesting and really, I would say, topical about what's happening nowadays, especially with those chatbots. And with that being said, happy to give everybody else the rest of their day. And thank you for joining us. And those workshops tend to happen once a month. So there are a few I've recognized who joined us from previous sessions. Thank you for that. And for those who are joining us for the first time, that's what you can expect. And we'll see you next time around. Thank you.
Thank you very much.